Today we're going to look at transforming absolute value functions. We have several parts to the absolute value function that we can look at. We have the a value we talk about, the h value, and the k. And of course, the absolute value is defined as these bars here. And of course, anytime we talk about a family of functions, we have a parent, what we call a parent function. And that's the most basic type of function in that family. In this case, we have y equals absolute value of x. The graph for that function looks like this. It makes a V shape, and it makes sense because we plug in a value, we get a positive value out. When we talk about transforming an absolute value parent function, we always talk about it in terms of the vertex. In the case of the parent function, y equals absolute value of x, the vertex is 0, 0. Here are two examples of absolute value transformations dealing with the k value. So the graph on the left has a +1 after the absolute value, and that's going to shift the vertex from 0, 0 up to 0, 1. The second example I've given here is the absolute value of x minus 2. And of course, that's going to move it down 2 units. So the new vertex will be at 0, negative 2, right here. So to sum up the k value, plus a value will move it up, and minus a value will move it down. Next, we're going to look at what the h value does, or the number added or subtracted to x within the absolute value symbol. A couple examples here for you. If we do absolute value of x plus 4, with the plus 4 being on the inside, that is going to move it actually counterintuitively left 4 units to give it there. I have another example for you here, where we're going to move the absolute value equation to the right 3 units, and that would be a minus 3 on the inside. So just remember, if you're inside the absolute value symbols, it's going to be opposite of what your intuition is. So a plus 4 will move it left 4, and a minus 3 will move it right 3. And this is because of the way the equation is written in the original parent function. You've got a minus sign here, so that basically reverses the pieces that you have. So this is really a plus 3, and that's really a minus 4. The next piece that we need to look at is what the a value does. So the part in front of the absolute value symbol. What is that going to do for our functions? Well, let's look at a couple examples here. Here's where we put a negative out front of our parent function, y equals absolute value of x. It's going to flip it upside down, but of course it'll leave the vertex at 0, 0 because there's nothing inside, like the h value, or k on the outside. Just flips it upside down. The next example, we're going to put a 1/4 in front, and that's going to make what I call a wider graph. Vertex doesn't move. It just basically lessens the y's in the table by 1/4. The last example here, in terms of the a values, is putting a number larger than 1 out front, such as 5. And I call these skinny graphs. Now, these are actually called a vertical stretch, and the purple one would be called a vertical shrinking. Now let's put all those pieces together. So here I've given you a absolute value function that's been transformed, and I'm going to ask you to write the equation given the graph. So the first thing we do is look at the vertex. The vertex here is 3, 1. So it's been moved right 3, up 1. And as you notice, it's also been flipped upside down. So how do we describe that in a function? Well, the first piece that we're going to need is the a value, and of course our k and h. So notice here the negative out front flips it upside down. And the 2 is going to make it a little bit skinnier than the parent function, but not much. And then our minus 3, as we talked about, is opposite of what you think. It's going to move it right 3 units. And then finally, the plus 1 on the end gives us our movement upwards by 1. So here's a nice little visual. If you need to take those in your notes, that'd be a good idea. Thank you. We'll see you on the next video.